We have been told a story about the aging brain, and the story goes like this. Your genes were dealt a certain hand, the clock runs down, and one day the lights start to dim. Dementia, in this story, is something that happens to you, a sentence written before you were born and read aloud somewhere around the age of 70 years. I want to tell you why that story is, for most people, wrong. Not softened, not, well, lifestyle helps a little. Wrong at the root. Here's a fact that should stop you cold. For roughly 2 million years, the human brain grew dramatically, relentlessly, one of the fastest expansions of any organ in the history of life on Earth. And then, in just the last several thousand years, it did something it had never done before. It began to shrink by an estimated 10 to 17% in a window that lines up precisely with one change: the shift away from meat and animal fat toward a grain-based diet. I'm Dr. Padda. At Region.md, my work is regenerative medicine, repairing the terrain the body is built on rather than chasing symptoms. And over the next 5 episodes, I'm going to make a case to you that the brain is a terrain organ like any other. Starve it, poison it, and it degenerates on schedule. Feed it and defend it, and much of what we call normal aging of the brain simply does not have to happen. Today, we start with the most basic question of all, and the one almost everyone gets wrong. What does your brain actually run on? Ask 100 people what powers the brain, and 99 will say the same word: sugar, glucose. It's in every textbook diagram, every cereal commercial's fine print, every "your brain needs carbs" headline. It's also not the brain's first choice. Here's what actually happens. When ketones, or the clean-burning fuel your body makes from fat, are available in the bloodstream, your brain preferentially burns them, not as a backup, as a preference. Large portions of your brain will run almost exclusively on ketones and fat as long as they're supplied, and only fall back on glucose when ketones run out. This isn't a fringe claim. We can watch it happen. In brain imaging studies using PET scans, the same scans we use to hunt for cancer by tracking glucose uptake, researchers put people into deeper ketosis and watched ketones climb to supply 60 to 70% of the brain's energy, even while glucose sat there at normal levels, available and ignored. The brain had a choice, and it chose fat. Why would evolution wire the most important organ in your body to prefer a fuel most modern people almost never produce? Because for almost all of human history, we did produce it. Fat-adapted, meat-eating, periodically fasting humans lived in gentle, on and off ketosis as a baseline. The brain didn't evolve on a river of sugar. It evolved on fat. Now here is where it turns from interesting to urgent. In Alzheimer's disease, one of the earliest and most consistent findings, showing up years, sometimes decades before memory symptoms, is that the brain's ability to take up and use glucose falls. Regions of the brain quite literally stop being able to burn their sugar. Researchers can see the dimming on a PET scan before a patient has forgotten a single name. For a long time, we assumed that dimming was the disease dying cells using less fuel, but there's a second finding that reframes everything. When you measure ketone uptake in those same Alzheimer's brains, it is largely preserved. The cells that can no longer burn sugar can still burn ketones. The engine isn't dead. It's been handed a fuel it can no longer process, while the fuel it can process is nowhere in the diet. This is why a growing number of researchers, including groups at Johns Hopkins, now describe Alzheimer's disease as type 3 diabetes, a state of insulin resistance and energy failure localized to the brain. The landmark review that named it laid out the case a decade and a half ago, and the evidence has only accumulated since. Think about what that means. If the brain in decline is energy-starved, but still capable of burning ketones, then the most obvious intervention in the world is to give it ketones. And when researchers have done exactly that, something remarkable happens. But that's episode 5. Today, I only need you to hold one image: a brain that is starving in a sea of sugar it can no longer use. Let me show you how deep this wiring goes, because it starts before birth. Pregnancy has been described by metabolic researchers as accelerated starvation. And that's not an insult, it's a design feature. As pregnancy advances, Mothers slip into ketosis faster and more easily than anyone else, sometimes on carbohydrate intakes that would knock a non-pregnant person out of ketosis entirely. Why? Because those ketones cross the placenta freely, and the exploding fetal brain of the third trimester requires them, both as fuel and as raw material, reconstituted into the fats that physically build the brain. It doesn't stop at birth. Breast milk is deliberately ketogenic. Even with the milk, sugar, lactose present, breastfed infants run on ketones because their brains demand it. And studies comparing breastfed to formula-fed infants find the formula-fed babies produce measurably fewer ketones. The default state of the human brain from its very first days is to be fueled by fat and ketones and built from fat, not to be run on a constant drip of dietary glucose. And here's the tell that this is a diet story and not an aging story. We do not have a single documented example anywhere in nature of a wild animal on its natural diet whose brain shrinks as it ages. Not one. Our closest genetic relatives, chimpanzees, were studied across the full adult lifespan, dozens of animals, brain scans across the ages, and while the human brains predictably shrank, the chimpanzee brains did not. Now, I want to be precise with you because precision is how you'll know you can trust everything else I tell you across this series. The authors of that chimpanzee study attributed the difference mainly to our unusually long lifespan, not directly to diet. That's their honest read, and I'll honor it. But it leaves a question hanging that longevity alone doesn't answer. Other long-lived mammals don't show this pattern either. Something about the human trajectory is unique, and the diet that changed in the exact window our brains started shrinking is the most modifiable suspect we have. We even see the fingerprint in the animals we've reshaped ourselves. Grain-fed domestic pigs have been measured with brains meaningfully smaller than their wild boar ancestors. And I'll be straight with you about that one too, because you deserve a doctor who reads the fine print. In that study, the reduction wasn't statistically airtight, and the pigs bred hardest for muscle actually had larger brains. What the study cleanly proves is not grain shrinks brains. It's the deeper point this whole series rests on. Brain size is not fixed. It responds to environment, to nutrition, to what the organism is fed. The brain is plastic clay, and diet is one of the hands shaping it. So let me put the pieces together and reframe the whole conversation. We look at brain scans of older adults, we see shrinkage, and we call it normal age-related atrophy. We've said it so many times it sounds like a law of nature. But step back. We have a brain that prefers a fuel most modern people never make. We have a disease process defined by that brain starving of the sugar it can no longer burn. We have every other animal in nature aging without this shrinkage. And we have a shrinkage that appeared in our own species in lockstep with a change in what we eat. What if what we've been calling normal aging of the brain is not normal at all? What if it is what decades of quiet metabolic starvation look like, etched into an organ? That is the reframe this entire series is built on. Dementia is not, for most people, a timer that switches on at the age of 70 years. It is the downstream result of a terrain problem, and the first pillar of that terrain is fuel. If your brain is an engine built to run on fat and ketones, then the single most important question about your cognitive future isn't what are my genes? It's what am I feeding it, and is it starving right now? Over the next 4 episodes, we're going to build the whole picture. Next time, what your brain is physically made of, and a widely prescribed medication that may be quietly blocking the supply line. A medication you should never stop on your own, but absolutely should understand. At Regan.md, we don't guess about this, we measure it. Your metabolic markers, your fuel status, the terrain your brain is actually living in. Because a starving brain is a fixable brain. And the first step is knowing whether yours is starving at all. If you want the full version of what I just covered, the actual studies, the mechanisms, and where the evidence is genuinely strong versus where it's still preliminary, I wrote it all down. It's a book called The Starved Brain, and the link is below. Every claim in it is referenced, so you don't have to take my word for anything.